In this video, I will talk about Tezos in general and about smart contract in Tezos. First, I will talk about Nomadic Labs. We are a team of more than 60 people contributing to developing the Tezos ecosystem. We do research and development of the Tezos protocol and the Octave suite. We develop tools and utilities for the Tezos ecosystem. We work on formal verification of the Tezos protocol and of Tezos smart contracts. And we provide support to industry partners and their Tezos-based projects. Finally, we work on communication, adoption, organized trainings, and research partnerships, for example, with INRIA or IMDEA. So I will introduce Tezos. It's a public blockchain, which is open source and has advanced support for smart contracts. The native token on Tezos is the Tez cryptocurrency, which we can also write XTZ. The Tezos protocol is based on a liquid proof-of-stake consensus algorithm, which consumes very little energy and therefore is environmentally sustainable. And it has a governance system that is integrated into the protocol and that allows Tezos to evolve on a regular basis in a democratic, transparent, and reliable way. Finally, Tezos is developed using languages like OCaml and tools like Mishokok that facilitate verification of the protocol and of smart contracts. So, as I was saying, Tezos is based on the liquid proof-of-stake consensus algorithm, and I'll say a little bit about how it works. So, for each block, a list of bakers is randomly selected among volunteer nodes. And in this list, the first baker is given priority to produce the next block. If this baker fails to produce a block in time, then the second one in the list may do so, and then if it doesn't, then the next one can do it, and so on, to ensure that the block is actually produced. So for each slot in this list, we select a baker randomly, and the likelihood of a baker being selected for that slot is proportional to the number of tokens it puts at stake. And it's a whole number of rows, and each row is currently 8,000 Tez. Also, users may delegate their tokens to a node of their choice. This increases the chance of that node being selected, and in return, these users receive a portion of the rewards that the baker may collect, in particular if it ends up adding a valid block to the chain. We can talk about the difference between liquid proof-of-stake and delegated proof-of-stake. Delegated proof-of-stake is used by some other blockchains like EOS or Lisk. And in delegated proof-of-stake, a limited number, usually from 20 to 100, of validators are elected by users based on their reputation or efficiency. But this incentivizes professionalization of validators since there's only a limited number of potential validators, and this can increase centralization. So liquid proof-of-stake was developed to address these issues and enforce decentralization. It does that in two ways. First, it has no limit on the number of bakers, and right now we have approximately 400 bakers on Tezos. And it also enforces decentralization by making it easier and safer for users to delegate to bakers. Let's talk about smart contract. The concept was proposed in 1994 by Nick Szabo, who is the inventor of BitGold. And the first precursor of a smart contract language was actually in Bitcoin scripts, that was created in 2009. But it's not really a smart contract language, as we will see. In 2013, Vitalik Buterin published the white paper that describes Ethereum, which is a smart contract platform. And in 2014, Arthur Breitman published the white paper that describes Tezos. In 2015, Ethereum was launched, and it was the first blockchain to support smart contracts. A bit later, in 2018, Tezos was launched, and along with it, Mikason, its smart contract language. So, in Bitcoin, we had a model based on UTXO and transactions. A UTXO means unspent transaction output, which are amounts that have not yet been spent. And at each block, UTXO is produced, called as Coinbase, and that is produced to reward the miner who created the block. And each transaction will spend a number of UTXOs and may produce new UTXOs. During that process, Bitcoin script is used to check for each UTXO that it can be spent by the transaction. So how does that work? So Bitcoin script is a stack language that can do simple computation, but it's very limited. It doesn't have any loop, and it's not Turing complete. So to validate the spending of an UTXO by a transaction, we basically concatenate two parts. The first part is a script provided by the transaction, which is used to unlock this UTXO. And the second part is a script that was already attached to the UTXO. So we concatenate those two parts and then run them. And the spending of the UTXO is only allowed if the output of the concatenated script is equal to 1. In practice, for security reasons, only 5 types of scripts are allowed. They only make it possible to check one or more signature, which we call a multisig. If we allow more types of script, this would risk more bugs and performance issues. But in spite of these limitations, it's possible to use Bitcoin script to store arbitrary data. So let's talk about smart contracts on Tezos. Instead of UTXOs, we have a set of accounts, and each account has an address and an amount of accumulated tokens, which we call the balance. On Tezos, a transaction is a transfer of tokens from one account to another. And a smart contract is a special kind of account that also has a dedicated storage and a program which is written in a very expressive language that can be used for computations, modifications of the storage, and to perform transactions. And an invocation of a smart contract entails a transaction which will transfer an amount of cryptocurrency tokens to the contract, transmit some data as the parameter of the contract, and will run the code of the smart contract program. So let's talk about data. It's important to keep in mind that the code of a smart contract only has access to a small amount of data. It doesn't have access to the whole blockchain. So that amount of data essentially consists of the value of the parameter that was sent when we made the call to the contract, the content of the storage that is dedicated to this contract, the address of the caller, which can be the direct caller or an indirect caller, and the amount of Tez that is being transferred during the call to the contract. Finally, it can have access to the balance of the account for the contract and to the level, which is the position in the chain, and to the timestamp of the block that carries the contract call. On the other hand, it doesn't have access to data from other deployed contracts and, of course, to off-chain data. So now that we understand what a contract has access to, let's see what a contract can do. And basically all it does is to produce two things. A list of operations that are calls to other contracts or token transfers, etc. And it also produces the new value of the contract storage. So a contract doesn't really do anything other than compute and return those two values. And after a successful call to a smart contract, the blockchain will update its storage with the new value and execute the list of operations that the smart contract returned. So in case of an error, it's important to know that everything is cancelled and the storage is then changed. So to recap, a smart contract has a number of properties. It's immutable, which means no one can change its code once it's deployed. But it's important to keep in mind that the effect of the code may depend on the data in its storage, which can change. It's eternal, it stays available forever. Of course, as long as enough people keep maintaining the blockchain. It's distributed, which means its existence doesn't depend on any specific third party, but it can use data provided by third parties, in particular through oracles. And finally, it's public. Anyone can read it, call it, and access to its data, but it may contain encrypted data and restrict access to its features. So why do we want to develop smart contract on Tezos? There are three main reasons to keep in mind. The first one is that Tezos is evolutive. Its on-chain governance systems allows the protocol to regularly improve its smart contract language, its performance, and it does it through a well-defined decision process. And basically, we have an update approximately every 3 months with no need for hard forks. This is really a great advantage. The second property is that Tezos is very well adapted for formal verification. Michelson, the native language of Tezos, is human readable and is designed to facilitate formal verification. And the Michelson interpreter has been formalized using the Coq proof assistant. Finally, and it's very important, Tezos is environmentally friendly. The liquid proof of stake consensus architecture is highly energy efficient, and compared to proof of work approaches, it's millions of times less energy hungry.